right, we are live. Did anyone have any questions or concerns about lesson 10?
Nope, I did not.
No, not too bad. Lesson 11 was a little bit different.
I'm a little shaky on 11, but
yeah.
I agree with both of you. So
okay. Well, let's go into our group quizzes then. Let me know when you guys have yours up.
I'm ready.
I'm ready to go.
Okay, you good, Scott?
Yeah, looking at it.
Okay, fabulous. I will start. Question 3. Find the margin of error for a 90% confidence interval when the standard deviation is 50 and the sample is 25. So the 90% Z-score is 1.645. Standard deviation is 50, sample is 25. Margin is, oops. Sorry, I did that wrong. Give me 1 second.
So for this one, do you have to do plus and minus?
So it's asking for the margin of error, so I think it's only one of them.
It's just the, yeah, it's just the margin, whereas the upper bound is where you add it to the mean. But we're just finding how much you add, basically. Okay, sorry, I have to replug this into my thing because I screwed it up. 1.645. Standard deviation of 50 and a sample of 25. That would be a margin of 16.45.
That's what I got.
All right.
1 second. So you're basically just doing 1.645 times 50 divided by the square root of 25?
1.645.
Yeah.
Yeah. Yep.
Yep, 16. That's what I got.
Okay.
Did you get that, Scott?
You know what? I was wrong. I think I'm in the wrong spot. I'm catching up. You guys go ahead.
Okay.
Okay. I'll go ahead and do number 4. It says, which of the following statements is true? The standard deviation squared is an interval estimator of the mean of the sample. The mean of the sample is a point estimator of the mean of the population. The mean of the population is a point estimator of the sample mean. Or the standard deviation is an estimator of the variance. Or is an interval of estimator of the variance. I don't even know that I was totally confused by all these answers.
It's the population mean is the point estimator of sample mean, right?
So is that the third one down there?
Because it's what's assumed. I mean, I'm a little confused about this too. But from what I understand, the point of a point estimator is that it's kind of what you assume in order to get your statistic.
Let's see.
Is that?
Dalen is saying yes, it's C also, but
Let me look at my notes for this. Things are getting weird here.
Let's see.
Because they're just one number that is used to estimate a parameter. Parameters are generally unknown values. If mu is unknown, how do we know if x is close to it?
Okay. Yes. Sure. So are we gonna go with C?
I think so.
I think C is the answer, but what does point estimator mean again?
The material says they're called point estimators because they're just one number that is used to estimate a parameter. So like, I think what that means is that typically the exact mean of the population won't be known, so we estimate that it's mu. And so that's why it's a point estimator,
Okay,
I think.
sounds good. I think I'm gonna have to go back and
So to me, it kind of sounds like B would be it. Just because it says it's one number that is used to estimate a parameter. Isn't a parameter like a whole group? And so, like, if you look at the book, it says a population parameter.
Right.
yeah.
Then the other one's a sample statistic.
Daleen says it's how far it can deviate from the mean and still be true. But I thought that was the standard. I don't know.
Okay, well,
I'm not entirely sure about that.
I'm gonna go with you guys and go on C on this one, and then
Okay.
I'll have to study that one a little bit more after.
Yeah, me too. All right, going on to the next one. Information. Gina wants to construct a 95% confidence interval for GMAT score. She knows the standard deviation is 113. She collects a simple random sample size of 64, and she computes the sample mean at 526. Use this information for the next 6 questions. So what is the point estimate for the true GMAT score? So this is like the last one, right? We do the, let's see, oh, never mind. So what did we do for the last time? 1.64. So 95% is going to be 1.96. Okay, 1.96, and then you would multiply that by, let's see, the sigma is, the standard deviation is 113. Divide that by the square root of the sample size, which is 64. And that is your answer, correct? So 27.685.
That's what I got for question 6. But I think question 5 just wants to know what the point estimator is.
Okay, so that's where I'm kind of confused on what the point estimator. So is that just 1.96?
I think it's one of these. I think it's either 526 or 113. Because it's just what we're using to come up with our statistic. So
I think it's 526 because I think there's a question like that in the homework also.
So the point estimate, is that the same thing as the sample mean then?
I think so.
So then it'd just be 526. Okay. Well, I think yeah. I think you're right. I looked at my notes and it's always the point estimate, parentheses, sample mean, plus or minus the margin of error. Okay.
right.
So I just calculated the margin of error.
Right. So you answered question 6.
Okay, sorry about that.
Oh, that's perfect.
This one, for some reason, this one was tricky for me. Okay.
Well, that's weird. It's like, it's a weird. This is where it gets weird, I guess.
So what did you guys get for the margin of error? Did you get 27.685?
Yes.
Yeah. Do they want it rounded at all?
Default is 3 points, but it doesn't say on here. Oh, I'm gonna put 3. See how that goes. I'll submit it first.
Sounds
Scott, do you want to take this one or do you want me to take this one?
Go right ahead. Thanks.
So, what is the lower limit of this confidence interval? And I am going to say that it's 498.315.
That's what I got.
so you subtracted it then.
Right.
Because it wants a
it's
lower one.
the lower point of, like, it's minus the margin of error.
Okay.
And so the next one is
What was that?
the upper limit of this confidence interval. And so then you would just add the 27.685 to 526. So I got 553.685.
That's what I got. Wait, 523.685?
I got, no, 553 is what I got.
Okay. Yeah, that's what I got too. That's what Dalen got too.
Thanks, Dalen.
Thanks, Dalen.
Okay.
Wow.
553.685.
Yep.
Okay. Okay.
It looks like Dalen's taking question 9 and he says it would decrease. What would happen to the width of the confidence interval if Gina increases sample size? And I agree with Dalen that it's decreased.
I agree.
Yeah. Because that would mean that they're more confident, right?
That's how I understand it.
The confidence interval decreases. That means they're more confident. Which
Yeah.
makes sense because you have a larger sample size.
Yeah.
Okay. Question 10. What would happen to the width of the confidence interval if Gina changed it to a 99% confidence interval? So the width would, it was 95 and she's going to take it to a 99. So it would decrease also.
I think it would increase.
I thought it would decrease also.
Really? So, okay, let me double check my notes then. So it says, as the level of confidence increases, the width of the confidence interval increases.
Okay.
But as the sample size increases, it decreases. Okay, there you go. So it,
Okay, so as sample size increases, the confidence interval will decrease.
increases.
But if the confidence interval, so if the confidence interval increases, then the width will increase also.
That's, yes. As the confidence level increases, the width of the confidence level increases.
Okay.
Yeah. So that would be an increase, right?
Mm-hmm.
Okay.
Only 4 questions left.
Okay, Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? Well, let's find out. Let's see, for a 95% confidence interval, the z-score is 1.96, meaning the sample required would be 246. Is that accurate?
Let's see.
1 second. Divided by 50.
How many? What did you get?
I got 246.
That's what I got.
So did you do 1.96 plus 400 divided
It's
by 50?
Times 400.
Oh, times by 400 divided by 50 squared.
Mhm. Yep.
Great. Yep.
That's a little bit wrong here. So 245.86.
Yeah, and then they said you always round up.
Oh yeah, that's right. 246.
You can have 0.86 persons.
Yeah.
Okay, so is this one mine?
Okay.
Okay. The mean salary of actuaries is $100,000 and the standard deviation is 36,730. You are interested to know if the mean salary for women actuaries is different than the population mean, but are not sure if it is higher or lower. You set up a hypothesis test with the level of significance as 0.05, and the null hypothesis is equal to 100,000. The alternate hypothesis is not equal to 100,000. You collect a simple random sample of 36 women's salaries and find the mean to be 111,000. Use this information for the next 3 questions. So, what is the lower limit of the 95% interval? So 95% is 1.96. Let's see. So I'm just looking at my notes. Let's see. So I got the lower level, the 95%. I got 88,001 and 53 cents. But it says round to the nearest whole, so I guess it would be 88,002. Anybody else get that?
I got 99 for some reason. 99,002.
Okay. Looks like Dalen got the same as me.
1 second. I'm almost done.
Okay.
So
Okay.
what's your margin?
So it's 95%. My margin was 11,998 and 47 cents. And I got that by going 1.96 times 36,730 over the square root of 36.
So I got the same margin. Then why would I have calculated this different? It must
Oh, did you go 111 minus? You went the sample mean minus.
Oh, I must have. I must have. That's what it is. Okay. Okay, so yeah, you're right.
So
Thanks.
88,002. It says round to the nearest whole number.
88,002. Yeah.
I hope that's right.
Okay.
So I'm a little confused on how you did that. Sorry.
No, you're good.
I did 1.96 times it by 36,730 divided by the square root of 36.
Yep. And that should have given you 11,998 and 47 cents.
Uh-huh.
And so then what you do is you take the population mean, which was 100,000, minus that margin to find the lower limit.
Oh, okay. And then to get the higher limit, you're going to add it.
Yes.
Okay. Okay, so if you add it, then it's 111,998.47.
Yeah, so it says round to the nearest whole number.
Or let's see, 111,999 if we're about to go up.
I don't know if we go up or
98 because I
Yeah.
only
Okay,
you
so
get 47 cents, so you just round it down, I think.
okay, yeah.
Okay, cool. And then the last question is, there are 3 requirements that need to be checked when computing a confidence interval for a mean. They are that a random sample is drawn from the population, that the standard deviation is known, that the sample mean is normally distributed, or all of the above. And I think it's all of the above.
I agree.
Okay,
Dang, I wish I had that one.
I know, right? I'm going to submit this and see how we did. Woo. Okay, so we missed 12 and 13.
Okay.
Wait. Yeah, 12 and 13 and 4, which is the one we were confused on. Okay, so maybe it is the population mean minus, or
The sample mean.
sample mean minus the margin.
I think it is.
'Cause
That's what I have in my notes. So yeah, you're right. It is a sample mean minus the margin.
so that would explain 12 and 13, and then
So I think 4 is the sample mean as a point estimator of the population mean.
the sample mean is a point estimator.
Yeah.
Number 4,
Yeah.
sample mean. Oh, so B.
Yeah. So on,
Yeah,
let's see.
I think you're right. I think you're right.
So for number 12, if we change it to the sample mean, you would get $99,002. Is that what you guys got?
1 second.
Okay.
Yeah, I did. $99,002.
And then for the upper bound, it would be $122,998.
That's what I got.
Okay,
Do you want me to try to submit mine and see what it says?
go for it.
Okay. Let me make sure I filled out 1 and 2 before I get those 2 wrong. Okay, we're good. Um, 100%.
Wait.
All right. Sorry, I'm just going to update.
Do you need to know any of the answers, or do you got them all?
I wrote them down. So,
Made it past that.
yeah, well,
After doing 11, I don't know if I look forward to this.
Usually I'm able to get the homework assignment done along with the personal prep before we do the group quiz. And I think that makes a huge difference rather But this week I only had time to do the individual prep for both of them. So I'm still trying to learn it all. But
Yeah.
How are you doing over there, Scott?
I'm mostly keeping up. You guys are really whipping through this stuff. But now I see that's how this whole thing is supposed to work. I'll be a lot more prepared next time.
Okay.
don't hesitate to ask questions or have us stop for a
I was
second.
gonna say stop us if needed.
Yeah.
This is a lot harder for me, actually. All the stuff we did before the test, it made more sense, and then it's like we've jumped into a whole different class to me.
Yeah.
Yeah, I agree. Yeah.
Oh, Dalen.
I was gonna say, is he still here? It looked like he needed help.
Subtracted.
It looks like he left the group chat. Oh no, he's still here. Yeah.
Oh, I don't know. He joined and then left and then joined and then left. I'll just write this in case it's still there. We subtracted the
Okay.
what the margin from the sample mean, right?
Yeah, it was a sample mean minus the margin.
Okay. Cool. So can I call you guys back on the next video?
Yep, you'll just send us another email like you always do.
Yeah.
Okay, cool.
Talk to you
Sounds
guys.
good.